Okay guys, welcome back again. We're going to talk about significant figures and measurements because we're going to get ready to start actually measuring things out in our lab, and we need to have the right numbers. All measurements are inaccurate. Precision of measuring devices is what we're limited to, and human error and faulty technique. So if you don't measure just right, sometimes your numbers come off a little bit challenging. So on this video, what I want you to do is write down the rules for significant figures and why it's important to have significant figures. Okay, has to do with measurements. So measurements need to convey precision, and what we talk about for precision in science is that if we're accurate, we're going to hit the same spot every single time, or get close to the target, I guess you could say. And if we're precise, we're hitting the same numbers or close to the same numbers every single time. So if you think about when you shoot an arrow at a dartboard or at a target, if you get close to the center of the target, you're accurate. If you hit the target the same place, nearly the same place every single time, no matter whether you hit it on target or off target, it's precise. Okay. There is a degree of an uncertainty, and significant figures tell us this. Okay, that's what SIGFIG stands for, significant figures. All right, so let's take a look at these measurements. Okay, if I say that this measured 0.6 meters, these are all exactly the same, right? But if you look here, we're thinking, oh, it's 6.61, but according to this, we know it's not quite 1, but it's at 0.607 meters. Okay, so this shows us our degree of inaccuracy. So significant figures in a measurement include, and I want you to start writing these rules down. Number 1, all digits that are known precisely. What does that mean? I'm going to show you here in just a minute. Plus one last digit that is estimated. So it's one that we think it's close to, or it's telling us it's close to. Okay. Non-zeros. Non-zero digits are always significant. So that's 1, 2, 3, 4, 5, 6, 7, 8, and 9. Those digits. All final zeros. This is where we get a little tricky. Zeros. Okay, so all final zeros after the decimal. Okay, so here's our decimal. Any zeros that are after a decimal place are significant. That means we have to have them in, or we have to count them, or they have to be there. Zeros that are between, again, here's another zero, between two other significant digits. So those ones that we talked about before, 1, 2, 3, 4, 5, 6, 7, 8, 9, or the ending zeros after a decimal point are significant. Okay, so for instance, this would have 3 significant digits because we have a 1, which is significant, a 0 after the decimal, which is significant, and then this one falls in between. This one would have 4, and this one would have 4. Okay. Zeros used for spacing are not significant. So for instance, 100, we're using these two zeros as spacers. There is only one significant digit here, just the 1. These zeros, okay, are spacers. Well, now you're going to ask, well, but these are after a decimal. Yes, however, they are not the ending zeros. They are leading zeros. So we call these leading. And I don't have my pen right now. Leading zeros. Okay? Leading zeros. That means that they're spacers. So this one only has 3 significant digits. Okay? And those are our 5 rules. So we always put a 0 in front of the decimal point. Okay? These are correct. I don't want to see this in my labs. Okay? I want to see 0.873. That means that these zeros in front are leading zeros. So this would have 3 significant digits, and this would only have 2 significant digits. This would still only have 3, but it's incorrect because we need to have a 0 here. Okay? Alright, so let's take a look at these and see if you can guess what these are. How many significant figures do we have? Well, at number 1, we only have 1. Just that 4. No decimal. These zeros don't count. And here, all these zeros, number 3, all these zeros are leading, so we only have 1. Here we have 2. 0 doesn't count. Down here, we have 1, 2, 3, 4, 5. No zeros, they all count. Up here, we have 4. See if you get these right. Okay? With this 2 counts. This one counts because it's in between. This one counts because it's in between. Here's a decimal. Here's our ending 0. That ending 0 right here does count, which puts these in the middle. Here we have 3. On number 6, we have 3. Why? Because these leading zeros don't count. This one does. Okay? Over here, what do you think? 1, 2, 3, 4, 5, 6. Again, this 0 counts. Alright, I want you to try these and stop the video and bring these to class. Let's see if you guys can figure it out. The only thing we did not talk about were these right here. This is called scientific notation. We don't worry about this stuff. So now, does that help you out? Do you think we could figure out how many significant digits we have? Okay, bring these to class. I'll check them in class. Have a good night, guys.